Let the video start from here. Are you miracle? So welcome to Organic Chemistry Part 2. We already did Part 1 in our last class. The Part 1 Organic Chemistry where I introduced alkanes. And we stopped exactly at isomerism. And we defined isomerism as when two or more organic compounds exhibit the same molecular formula but different structural formula. When two or more organic compounds exhibit the same molecular formula but different structural formula, we say isomerism has occurred. So in our last video, you can see this is Organic Chemistry Part 2. In the last one, we did Part 1, and we defined isomerism already. This is just a recap. We gave example, butane and 2-methylpropane. Looking at butane and 2-methylpropane, we agree that they have the same number of carbon, 4 carbons, and they have the same number of hydrogen, 10 hydrogen, 10 hydrogen. But when we want to draw out their structure, they have different structures. That's what we're talking about in isomerism. When two compounds have the same number of carbon and hydrogen, another constituent are the same, but when you're drawing their structure is different. Let us see what happens between butane and 2-methylpropane. You can see this is butane. Now for 2-methylpropane, let's draw the structure of 2-methylpropane. You draw propane. Propane means 3 carbons. 2-methylpropane, propane means 3 carbons. Then methyl group on the second carbon. For this carbon 1, carbon 2, carbon 3. In the last two, I taught naming, a bit of naming, right? And structures, how to name organic compounds. We even took some questions on the past questions. This, if you missed that class, the video is there for you. Just message me so you can get the video. Now, this 2-methylpropane, so the structure is different. Class, this type of isomerism that exists in the alkane family, because butane belongs to the alkane family. This type of isomerism that exists in the alkane family is called chain or nuclear isomerism. Chain or what? Oh, we have different types of isomerism class. Chain or nuclear isomerism. We have types of isomerism. We have chain, also known as nuclear isomerism. It is typical of the alkane family. So if you ask in the exam, which of this type of isomerism is exhibited by the alkane family, it's called what? Chain or nuclear isomerism. But we have other types of isomerism apart from this. We have positional isomerism. We have positional isomerism. We have functional group isomerism. And we have geometric isomerism. Also last week, I remember I gave a formula, right? To determine the number of isomers an alkane can produce, right? 2 raised by n minus 4 plus 1. If you remember, I gave a formula to determine the number of isomers an alkane can produce. 2 raised to the power n minus 4 plus 1. Because alkanes, isomerism in alkanes, the alkane family begins from the 4th carbon. Isomerism in the alkane family begins from the 4th. So looking at the alkane family, I told you they exhibit chain or nuclei. So this type of isomerism is exhibited by the alkane family, and the exhibit chain or nuclear isomerism. And isomerism begins from the 4th carbon member, butane. So it means that the first 3 members of our alkane family don't exhibit isomerism. The first 3 members of the alkane family do not what? Exhibit isomerism. So class, for the 4th member, butane, the exam could be asked, determine the number of isomers that butane can produce. Formula to determine the number of isomers an alkane member can produce is 2 raised by n minus 4 plus 1, where n represents the number of carbon. Where n represents the number of carbon. Number of isomers that an alkane can produce is 2 raised by n minus 4 plus 1, where n represents the number of what? Carbon. So we know that but means that you have 4 carbons. So it means that for butane, n is 4. Number of carbon is 4 for butane. So putting 4 into this formula, we can determine exactly the number of isomers butane can produce. We're going to say 2 raised to the power 4 minus 4 plus 1. 2 raised to the power 4 minus 4 plus... Now, 4 minus 4 will give us 2 raised to the power 0. 2 raised to the power 0, it means 1. 1 plus 1 is 2. Please, where is that my guy? Let me warn them. They should leave that place. I'm recording the class. No matter how low they are talking, it's entering the video. Be fast. They should please excuse us. there's a record, the class is being recorded. That's more thing they are saying now, is distracting. So you see that butane can produce 2 isomers. And I said last week that every organic compound has, every organic compound is an isomer of itself. Every organic compound is an isomer of itself. So when you are asked to list the isomers of an organic compound, the first isomer you should list is the organic compound itself. Class, for example, if you want to list the isomers of butane, the first one we'll list is butane itself. So class, if you want to list the isomers an alkane can produce, first list the butane. For example, we have determined the formula now that butane has 2 isomers, right? The first isomer of every organic compound is the organic compound itself. So the first isomer of butane is N-butane, the straight chain form of butane. Class, without any branches. The first isomer of butane is called what? N. Class, this N means straight chain. That means there's no branch. There's no what? Look at butane, 4 carbons without any branch. N-butane, no branch. This is the first isomer. Any other isomer of butane will be called an isobutane. Iso what? For example, that second isomer of butane, which was 2-methylpropane, is isobutane. It's also called iso because iso means isomer of butane, 2-methylpropane. How do we get 2-methylpropane from butane? Please follow. This video will make sense. If you are just joining and you'll be lost a bit, it's normal. Except maybe you already had a little foundation in organic chemistry. But if you don't, you'll be lost a bit. But one thing I should find solace in is that when you get home, the first video is there. And when you've watched the first video very well, this second video is also there to now rewatch again. You get? And I'll grab everything. Please, if you've registered, I've not added it today. There's a separate group for people that have registered, paid for the class. I know we have a general Jamb group, Abi. There's a separate group for only those that have registered. That's why I usually drop the link to the videos. So please message me so you can be added to that particular one. It's a paid members group apart from the general group. So please message me if you have registered and you have not been added there. So class, 2-methylpropane. How do we get 2-methylpropane, class? Class, you're going to cut off 1 carbon. This butane, 1, 2, 3, 4. You want to form an isomer of butane, you have to clean off 1 carbon and make it a branch. So instead of 4 carbons, you now have 3 carbons. 1, 2, 3. And class, this 4th carbon you cut off will now come and be a branch. Class, when you want to make a carbon a branch, it is not wise to put it at the ending carbons, because if you put it at the ending carbons, it just forms part of the chain again. You just repeated the same thing. So you want to put it here too, you just repeated the same. The best place to put a branch to make sure that it can actually be a branch is at the center carbon. So I remove this CH3. Class, all these places are filled with hydro. After carbon, the most popular element in organic compound is hydrogen. Filled with hydrogen, filled with what? Hydrogen. So it means that this CH3, I've cut it off. I want to form an isomer of butane. The isomer means they have the same carbon but just that different structure. So I want to form a different structure of butane. Plus, in order to ensure that you actually form a different structure of butane, make sure that you're not putting this carbon here at the ending or this place. Put it in the center. That way, you know that it can never be part of the chain. So this is the chain 1, 2, 3, and this is clearly a branch. A branch must not have any link to the main chain of an organic structure. Very important. When you want to make someone a branch, it must not have any link to the main chain. This is a branch now. And this branch, because this is now from butane, but means 4 carbons. This is now propane, 3 carbons. This guy now becomes a branch, 2, and it's on carbon 2, so it's called 2-methyl. This is a methyl group. And I said in the last class, when naming organic compounds, the branch is mentioned first. Then what ends the naming is the parent name. The chain 1, 2, 3 is propane. So this 2-methyl, because this methyl group falls on the second carbon, then propane. Also, when naming organic compounds, class, notice between a number and an alphabet, we put an hyphen. Put a what? An hyphen between a number and an alphabet. So we want to name organic compounds. Don't just write 2 and write M like that. An hyphen is between a number and an alphabet. But between a number and a number, you put a comma. Put a what? Comma. So this is isomerism that exists in alkane. We went further, I think we did pentane, right? And we looked at isomers in pentane. Pentane has 5 carbons. Pent means 5, so 5 carbons. When you watch the video, you understand why pent is 5, because I started by saying if you have 1 carbon in organic chemistry, there's a name we call you mets. Anybody that has 1 carbon, your naming must start with mets. If you have 2 carbons, your naming starts with et. If you have 3 carbons, your naming starts with pro. 4 carbons, your naming starts with but. 5, pen, 6, x. So pent, anytime you hear pent, just know that it's 5 carbons. That's the first foundation you should know. Meaning that you want to know the number of isomers pentane will produce, you use the formula 2 raised by n minus 4 plus, where n is now what? 5. N is what? Because pentane has 5 carbons. So that will be 2 raised to power 5 minus 4 plus, for n means number of carbons. Now 5 minus 4 is 1. Is what? So 2 raised to power 1 plus 1. 2 raised to power 1 is 2. 2 plus 1 is what? 3. 2 plus 1 is 3. Meaning that pentane can produce 3 isomers. Pentane will produce 3. Let's now find out what could be the 3 isomers of pentane. What could be the 3 isomers of what? Pentane. Let's find out. The 3 isomers of pentane, the formula has told us that we produce 3 isomers. Do not forget that the first isomer of every organic compound is the straight chain form of that organic. So the first isomer of pentane is pentane itself. This straight chain pentane. Now the second isomer will be you cutting off 1 carbon and making it a branch. So instead of 5 carbons, we now have 4. But this 5th carbon cannot exist in the ending carbon. If not, it should just be part of the chain again. It must be either here or in any of these middle carbons. I mean, let's put it here. So we have cut off 1 carbon and put it as a branch. And when you cut off the carbon, it also carries this 3 hydrogen with it, right? So that's why we have CH3. Now, you see that this guy can never be part of this chain because this is the chain 1, 2, 3, 4. Remember, we have 3 isomers, so this must be the second isomer. 4 now means that it's no longer pentane, it's now butane, right? But you mentioned the branch before the butane. We know that the name of this structure is butane. But mention the branch before the butane. The branch is 2-methyl. 2 what? Methyl. Butane. 2-methyl. Butane. 2-methyl. Butane. Now, but the formula told us that we have 3 isomers. So far, we have 2. This one is N-pentane, right? So anytime you see N, it means straight chain without any branch. N-pentane, 2-methyl butane. To get the third isomer, it means you must cut out another branch. You must cut out another what? So we'll cut out 1 more carbon. Remember that here, this was carbon we cut out to get this. Put this branch here, right? We'll cut out this one. And it means that we have 3 carbons remaining. 1, 2, 3. Remember that there's already a branch here, CA3. Now the branch cannot be here, cannot be here. They are the ending carbon, right? It means that it must come to this middle carbon on top. It cannot be here, it cannot be here. This 1, 2, 3. So this is now propane. We know that the name of this structure is pro. So 3 carbons means pro. But this is a branch, this is also a branch. How will we know the name? Mention the branch before the name. Mention the branch before the name. So it's going to be 2-methyl, another 2-methyl. So we'll call it 2,2-dimethyl. 2,2-dimethyl propane. 2,2-dimethyl propane. 2,2-dimethyl propane. 2,2-dimethyl pro. These are the 3 isomers of pentane. You can apply the same method to determine isomers of anybody. Hexane, heptane. You can use this method to determine the isomers. Now, class, all these isomers we just looked at is under chain or nuclear isomerism. It's under chain or nuclear isomerism. Okay, so we are done with nuclear or chain isomerism. We now want to go to positional isomerism. Write down positional isomerism. Positional isomerism exists between 2 or more compounds having the same molecular formula but with difference in position of the functional group or bond, double bond, multiple bond present, put it that way. Positional isomerism exists between 2 or more organic compounds with the same molecular formula. Positional isomerism exists between 2 or more organic compounds with the same molecular formula. Positional isomerism exists between 2 or more organic compounds with the same molecular formula, but with difference in the position of the functional group or multiple bond present. but difference in the position of the functional group or multiple bond present. But difference in the position of the functional group or multiple bond present. But difference in the position of the functional group or multiple bond present. Example exists between, you can see positional isomerism in the alkane family, also exists in the alkyne family. Example of families that exhibit positional isomerism: alkenes, alkynes, alcohols, even the ketones can exhibit positional isomerism. Later on, we come to functional group, you will know all this functional group. The ketones, also known as the alkanones, exhibit positional isomerism. The ketones, also known as the alkanones, exhibit positional isomerism. Now, if you look at alkene, for example, let's look at butene. Is it finished? Are you sure? Did you check well? Look at this. We have, in this structure, you see that double bond is found in between the first and second carbon. And there was something I said in the last class when treating alkanes. This carbon 1, this carbon 2, carbon 3, carbon 4. So this boots for class, this boots has a number, boot 1 in, this boot 1. Because anytime there's double bond between two carbon numbers, we ascribe that double bond to the lesser carbon number. I said it in the last class. That anytime there's a double bond between two carbon numbers, we ascribe the double bond to the what? Lesser carbon number, which is carbon 1. We ascribe the double bond to the lesser carbon number, which is carbon. So this boot 1 in, this boot 1 in. Now, we can also draw another structure of 4 carbons, but this time around, double bond has moved to carbon 2 and between 2 and 3. This carbon 1, carbon 2, carbon 3, carbon 4. Remember I also said in the last class that carbon now only have 4 bonds and I explained why, right? Now, between 1 and 2, this 2 and 3, you give it the lesser number, 2. So this boot 2 in. Class, this is positional isomerism between boot 1 in and boot 2 in. If you don't want to say boot 1 in, you can as well call this 1 boot in. 1 what? You can as well call this 1 boot in, and you can as well call this 2. Notice there's an hyphen between a number and an alphabet, 2 boot in. 1 boot in, 2 boot in. This is positional isomerism because it's just difference in the position of the multiple bond present. And that makes it what? An isomer. But this can also exist in alcohols class. If you look at, like we said, example alcohols, one butanol and 2 butanol. Butanol, anytime you hear someone ending with O, just another person has an OH group present somewhere. Like this 4 carbons, but it's ending with O. This another 4 carbons, but the OH has now moved to the second carbon. That's what's called position, just difference in the position of the functional. This one is carbon 1, this OH groups on carbon 1, this 2, 3, 4. But here the OH groups on carbon 2. So this 1 butanol class, anybody that has OH ends with nol is an alcohol. 1 butanol, and this is what? 2 butanol. Just difference in position of the functional group or multiple bond present. Makes it what? Positional isomerism. While we're taking our time to teach this, Jamb, you need to be well versed. If you are writing chemistry, you want to get 90 at least over. You need a good score in your Jamb, in your organic chemistry. Now class, let's look at functional group isomerism. Next one I want to look at is functional group isomerism. Class, functional group isomerism exists between two compounds with the same molecular formula but different functional groups. Exists between two compounds with the same molecular formula but different functional groups. So they have the same molecular formula, but when you are drawing out their structure, because they have different functional groups, the structures will be different. They have the same molecular formula, but when you are drawing out their structure, because they have different functional groups, their structures will be different. Same molecular formula, but different functional group. Example of functional group isomerism exists between ethanol and dimethyl ether. Example of functional group isomerism exists between ethanol and dimethyl ether. Ethanol and dimethyl ether. Class, if you look at ethanol, when you hear null, it means that you have an OH group, right? Et means that you have 2 carbons. So these are your name organic compound. Et, the beginning of your name tells me how many carbon I will draw. If I hear met, I will draw only 1 carbon. I may not know how to draw the remaining thing, but I know that met means 1. That's how you start learning organic compound. If you hear et, you just draw 2 carbon, even if you don't know what to do. Pro, 3. Boot, 4. Paint, 5. Now when you draw 2 carbons, the next thing I know that every carbon must have 4 bonds. So this is 1, 2, 3, 4, 1, 2, 3, 4. You have gotten the skeleton of the structure, the framework of the structure. Now you know that all means that there's an OH somewhere. If there's no number, it means that it's on the first carbon. Now fill up the other spaces with what? Hydrogen. Because anytime you are finished drawing your structure and there's this space, fill the other spaces with what? Hydrogen. After carbon, hydrogen is the next popular element in organic compounds. After carbon, hydrogen is the next popular element in organic. So this ethanol, class, this is what? Ethanol. Now, dimethyl ether on the other hand, is a different functional group because it consists of dimethyl means 2 methyl groups. Plus this O, anytime you see this O, it's called the ether functional group. Dimethyl ether, when you see this O in the center, it represents an ether functional group. Dimethyl, 2 methyl groups, ether functional group. Plus, watch the number of carbons here, number of hydrogen and number of oxygen, and watch the number of carbon, hydrogen, and oxygen here. You see that they're exactly the same. Meaning that they have the same number of carbon, number of hydrogen, and number of oxygen. Just different functional group and different structure. Obviously, the structure is different. Look at this one structure, oxygen in between what? 2 methyl groups. This one structure has an OH group and a typical core structure. So this is functional group isomerism. The next one we want to look at now is geometric isomerism. In geometric isomerism, we have the cis and the trans. It's typical of the alkane family. Geometric isomerism is typical of the alkane family. We have the cis isomer and we have the trans isomer for geometric isomerism. We have the cis isomer and we have the trans isomer. When you hear cis, it means together. When you hear trans, it means apart. When you hear cis, it means together. When you hear trans, it means apart. Cis means together, trans means what? Apart. Or away from each other. Class, in the cis isomer, similar functional groups are found on the same plane of the structure. But in trans isomers, similar functional groups are found on opposite planes of the structure. Good example, if you look at this, we have H, we have H, we have CH3, and we have CH3. Class, let us draw the plane that cuts across this structure like this. And you find that on this side of the plane, we have similar compound, hydrogen and hydrogen. And on this other side, we have similar compounds together. This is a cis isomer. This is a what? A cis isomer. Now talking about a trans isomer. So class, this cis, and let's look at trans on the other hand. This time around, this CH3 will be on the opposite side of the plane, and the hydrogen groups will also be on the opposite side of the what? This is a trans isomer. So when you want to start the naming of this compound, you say cis, then you now name accordingly. Let's try naming this. Let's try naming this. You say cis, then you name accordingly. The other one you say trans, you name accordingly. So here we are going to say carbon 1, carbon 2, carbon 3, carbon 4. So class, this essentially butane, but butane because the carbon, the other one between 2 and 3. So give it to 2. So you're going to say cis. You cannot say cis 2 butane. Cis what? Or cis butane. Anyone you want to call it. Cis butane or cis 2 butane. Why do we say 2 butane? Because the double bond is count between carbon 2 and what? 3. Always give it to the lesser number 2. Anytime there's double bond between 2 carbon numbers, give it to the lesser number. So this is carbon 1, 2, 3, 4. So this is a chain. This is actually a what? Chain. And looking at this is just still a chain. 1, 2, 3, 4. It's not compulsory the carbons are spread out like this before you say it's a chain. 1, 2, 3, 4. It's still a continuation. But this is now trans, still between carbon 2 and 3. Trans 2 butane. Trans what? 2 butane. Trans 2 butane. Now, Clara, let's really go to functional groups. Write down functional groups. Let's study the different functional groups in organic compounds. Functional groups. Functional groups. Let's look at functional groups. Functional groups are groups of atoms or ions that determine the chemical identity of an organic compound and also determines what? How the organic compound will react. Class. Functional groups are groups of atoms or ions or bonds. A functional group can be a bond. Class. If someone asks you what is the major functional group in alkane, is the double bond. Do you know that this double bond in alkane is the major functional group in alkane? The triple bond in alkyne is the major functional group in alkyne. Any component of an organic compound that determines the chemical identity, the chemical reactions, the chemical composition of the organic compound is termed the functional group. So the functional group determines how the organic compound will react in the chemical reaction. So this double bond determines how alkane reacts. Because anytime alkane wants to react, nothing will happen in alkane until the double bond is broken. I've never seen an alkane cannot react without the double bond breaking down first. If the double bond does not break down, an alkane will not react. So anybody that wants to react to an alkane must first overcome that double bond. Same thing with alkynes, triple bond. So a functional group doesn't necessarily have to be an atom. It could be a bond. So when defining functional group, we say well, it's a group of atoms. It could be an ion or ions or multiple bonds that determine the what chemical identity of the organic compound and also determines how the organic compound will do what? React. It determines the chemical reactions of the organic compound. How the organic compound will do what? React. Functional groups. Determines how the chemical compound will do what? React. And class, when looking at major functional groups, you find out that all organic compounds are simply, remember when I gave you this family alkyls? Class, the alkyls are usually one hydrogen less. So we use them to teach functional groups. Or to explain functional because they are one hydrogen less. They always lacking. If you look at methyl, it's 3 hydrogens. So it leaves space for one functional group to come in and complete it. So alkyls are not a complete family. They are always incomplete with one hydrogen less. So a functional group or a bond, anybody can come and fill them up. So they are up for the taking for any functional group to fill them up. So if OH comes in here, it becomes an alcohol. So alkyl can easily change to anybody. If nobody wants to fill it up, it just turns to a brand. 2 methyl propane, 3 methyl this. It turns to a what? So if OH fills it up, it becomes an alcohol. If it is COOH, it becomes an alkanoic. If it's C double bond O, like this, if there's no bond here and there's oxygen here, it turns to what? An aldehyde. You can still different things, alkyls. So when explaining functional group, we use alkyls a lot. So they're usually lacking one hydrogen less, and we represent them with the symbol letter R. So if someone says, and the general formula is Cn, of course, H2n plus 1, as I said in the last class. R. So if it is OH that's attached to the R, we say it's an alcohol. So the first functional group we want to look at, we have alcohols. Major functional groups, we have families. Apart from alkane, alkynes, we have alcohols. We have alkyl halides. Alkyl halides, also called halogenal alkanes. Halogenal what? Alkanes. We have aldehydes and ketones. Aldehydes are also called alkanals. Ketones are called alkanones. We have alkanoic acids. Alkanoic acids. Alcohols. Alcohol. We have esters. We have ethers. We have amines. We have amides. We have nitrites. For Jamb, we'll stop here. For Jamb scheme. Key families and their functional groups is what we're looking at now. Class, in each of these families, do you know even the functional group determines the naming of the organic compound? It's because alcohols contain OH and naming end with OS. Each of them have a key functional group. So we want to look at all these functional groups, such that if any of these families come out in your Jamb and you have to name them or draw their structure, you shouldn't have any problem. You should be familiar with them. You should be familiar with them. Some of us that are in school already, yeah, I'm sure this should be bringing back some memories, right? Chem 132. Yes, you did something like this. I don't know if you still remember them, but it's good. It's good refreshing memory. I think a little bit that are in school already, you should have a huge advantage. You shouldn't see Jamb and not score anything less than 280. You are falling your hand, because you've been in the system. You're in 100 level. You're come over in 200 level. You know what is 100 level here? So it's 100 level student here. So anybody that is in school is in 200 level here. You're in what level? You're in 300 level. You're in 200. You're in 200. So you pass through the system. You know, you've learned some of these things halfway, one way or the other. So this should be like a revision, refreshing your memory. So that means that you like 300 level. You did it 2 years ago when you're 100 level. Miracle did it last set. You did it last. So you should be a challenge to you that what should be Jamb. So that's why I was asking some people, have you gotten their past questions? Some of you have not still gotten till now. Miracle, have you gotten now? Have you gotten perfect? You have. Get your past Jamb past question. You are delaying us on what we want to do. Because it's not something that only our people will do, our people will not do. We are not already much. This is a private class. So imagine from people don't still have it now, we're now still divided again. So please, everybody should get it. Please. Please. So we can start. There's something I want us to do. You clear your Jamb. You clear your Jamb. I know what I'm saying. This is not the first time I'm doing it for students. Because how many things do you want to read in Jamb? Let's be honest. Jamb is very vast. Do you know how many topics are in chemistry Jamb syllabus? Do you know there's a whole full book that contains syllabus chemistry? They used to give that. I don't know if they still give that thing when you do Jamb. Or that they used to sell it then. But then they used to give it. How many things do you want to read? And they will bring out 40 questions, Abby. So you are reading for 40 questions. It means that how many? I'll be 50 or 40. 40. You are reading like Like all this organic chemistry we are doing, I might just be for 5 questions we are doing this whole topic for. So it's less rewarding when you are trying to cover everything in a course. But it's more specific when you're using past questions. It's more direct. It's more what? Of course, teaching is still important. There are some key topics that you should just let students have an idea about. So when they enter the exam, they can still know what to do, you understand? But balance it with what? Past exam questions too. Person is more direct. You see that there are some topics that they never bring out because it's just 40 questions they want to set. But there are some they love a lot. Like that solubility. Check every year of Jamb, the solubility, one question. It's not much, just one, but to come out, at least that one is short. There's no way they will not bring something on organic. But organic is like half of the chemistry, so they will feel somewhere they don't bring organic one way because chemistry is very into inorganic, and so half of it is organic. But the organic now, they cannot bring everything organic. There's still experimental chemistry, there's nuclear chemistry. Let's say they bring 5, 6, or even let's say 7 here. Out of 40, they have even tried for you. They will go to other aspects and also bring. So it's broad. So even if they give you the whole year, you cannot finish the whole chemistry in Jamb. It's much. Not talk about when you have just 2-3 months. So as you are learning small, you will be giving ourselves past question challenge, whereby everybody goes and do this here, will come to class, resolve it. That way, we're making faster progress. So that what we are teaching in class with that one, marry the two together. See how you will not blast your Jamb. By the time you're doing Jamb, consistently working with Jamb past question every day. And I'm saying this, see that when that's why some of you that were in school back then, I used to shout up, I used to think I want to sell my past question. No. Am I selling Jamb past question? No, you need it. It's not because I'm selling. When you need something, you do as I'm talking about tomorrow, say because you want to sell this past question. I'm not selling Jamb past question. But when I say you need something, you need, I will not get one that I buy Jamb past question. But you need it. Go and get it. Eh? So when everybody has gotten it, like everybody have not gotten it, you are delaying us now. So it's you have not gotten a miracle, just join us today, so I'll give you, I'll excuse you. Oh, you have. Sharp, sharp, sharp. You two, you have not gotten get. Eh? Okay, you have. So it's just you. So you're the one delaying us now. Get Jamb pass. He said, oh, it's not 4K or 3K. It's not, so just get it. Let us work. Let us. But we have limited time. So that we'll start working with us in biology. We go and do it. Chemistry, we go and do it. Then we'll resolve its solutions. Now, alcohols. They contain the OH functional group, right? The major functional group in the alcohol is the hydroxyl. Write down. The major functional group in the alcohol is the hydroxyl functional group. The major functional group in alcohol is the hydroxyl what? Hydroxyl functional group. The major functional group in alcohols is the hydroxyl functional group. The major functional group in alcohols is the hydroxyl functional group. So class, what makes up alcohol basically is alkyl group plus OH. An alkyl group plus what? OH. So if you have one carbon and you have OH, you are methanol. The enemy end with all. So one carbon means met, right? What will determine your engine is your what? Your functional group all. But met is the number of carbon. If the carbon increases to 2, what will it now be? 8. 2 carbons means 8, right? Ethanol. If the carbon increases to 3, proper. 4, butanol. So you see it. So the number of carbons determines how the naming begins. The OH determines the ending of the naming. Now, these alcohols, one important Jamb aspect of this alcohol is alcohols can be classified into 3. We have primary, right down. Alcohols can be classified into 3. We have primary, we have secondary, and we have tertiary. We have primary, we have secondary, and we have what? Tertiary. Alcohols can be classified into primary, secondary, and what? Tertiary. For the primary alcohols class, we classify them depending on what? The carbon behind the OH group and the number of hydrogens contained in that carbon. We classify alcohols into primary, secondary, and tertiary depending on the carbon bearing the OH group and the number of hydrogen contained in that carbon. The carbon bearing the OH group and the number of what? Hydrogens contained in that carbon. the carbon bearing the OH group, and the number of hydrogens contained in that what? Carbon. Will determine whether you're primary, secondary, or what? Tertiary. Now, for a primary alcohol, if I look at this carbon, so how do you determine a primary or secondary or tertiary alcohol? Go to the carbon that's carrying the OH. Go to the carbon carrying the what? OH group, and find out how many hydrogens are attached to its class. For a primary alcohol, write down. For a primary alcohol, the carbon bearing the OH group has 2 hydrogens or more attached to it directly. For a primary alcohol, the carbon bearing the OH group has 2 or more hydrogens directly attached to it. For a primary alcohol, the carbon bearing the OH group has 2 or more hydrogens directly attached to it. For a primary alcohol, the carbon bearing the OH group has 2 or more hydrogens directly attached to it. For a primary alcohol, the carbon bearing the OH group has what? 2. Know the word 2 or more. Some it can be 2, it can be more than 2. 2 or more hydrogens directly attached to what? To it. For a primary alcohol, the carbon bearing the OH group has 2 or more hydrogens directly attached to its primary. For a secondary alcohol, write down, the carbon bearing the OH group has only 1 hydrogen attached to it directly. For a secondary alcohol, the carbon bearing the OH group has only 1 hydrogen attached to it what? Directly. This is a secondary alcohol class. For a secondary alcohol, the carbon bearing the OH group has only 1 hydrogen attached to it what? That you can see, there's only 1 hydrogen attached to the carbon bearing the OH group. This 1, 2, 3. This is propanol, or we can call this 2-propanol. 2 what? Because the OH group is on the second carbon. 2-propanol because the OH group is on the second carbon. Secondary alcohol. So in the exam, you could be able to following is a secondary alcohol. This is what you look out for in the exam. Tertiary alcohol, on the other hand, tertiary alcohol, the carbon bearing the OH group does not have any hydrogen attached to it directly. For tertiary alcohol, the carbon that is carrying the OH group does not have any hydrogen attached to it. Look at this tertiary alcohol. The carbon that is carrying the OH group has no single hydrogen attached to it directly. The carbon bearing the OH group does not have any hydrogen attached to it directly. Instead, there is a methyl group attached to it. And the name of this alcohol, this is the chain 1, 2, 3. So this is a branch. This 2-methyl propan 2-ol. 2-methyl propan 2-ol. 2-methyl propan 2-ol. 2-methyl propan 2-ol, because 2-methyl because the methyl group is on the second carbon. Propan 2-ol because the OH group is also on the second carbon. 2-methyl propan 2-ol. Tertiary what? Alcohol. So when you recognize tertiary alcohol, you find out that there is no what? Hydrogen attached to the carbon bearing the OH group. There is no hydrogen attached to the carbon bearing the OH group. Then you say that that's a tertiary what? Alcohol. Class, I'd like to quickly go to aldehydes because there's a relationship between alcohols and aldehydes and ketones. So I will come to alkylides, but let me quickly do this so that I can link what's the relationship between them. Class, aldehydes, write down, and ketones. We are going to study them together. Aldehydes and what? Because they actually contain a similar functional group, just different positions. Aldehydes and what? Aldehydes and ketones, they actually contain similar functional groups, just different positions. Aldehydes and ketones contain similar functional groups for different positions. Write down, aldehydes and ketones contain similar functional groups but different what? Positions. They contain the carbonyl functional group. They contain the what? Carbonyl functional group C double bond O. This is the carbonyl functional group C double bond what? O. Is the carbonyl functional group C double bond O. They contain the carbonyl functional group C double bond O. Contains the carbonyl functional group C double bond what? O. Class, but different position, because in the aldehydes the carbonyl functional, write down note. For aldehydes, the carbonyl functional group is found at the end, at the ending carbon, that the terminal carbon. Put it at the terminal carbon. Note, carbonyl functional group in aldehyde is found at the terminal carbon. Carbonyl functional group in aldehyde is found at the terminal carbon. It's found where? At the terminal. Carbonyl functional group is found at the terminal carbon for aldehydes. But for ketones, it's found at the middle of the carbon chain. It's found where at the middle of the carbon chain. Ketones is found at the middle of the carbon chain. Aldehydes is found at the what? Terminal carbon. Ketone is found at the middle. This is carbonyl group C double bond O. When you see an organic compound containing C double bond O, just know that it's what? Either an aldehyde or a ketone. Question now remains, what makes an aldehyde? If you see the carbonyl group at the end, it's an aldehyde. If you see it in between the chains, it's a ketone. It's a what? Ketone. Class. Another thing that differentiates aldehyde and ketone is that carbonyl group of aldehyde contains hydrogen. Note, write down. The carbonyl group of aldehydes contain what? Hydrogen. But the carbonyl group of ketones don't contain hydrogen. That's another differentiator. Carbonyl group of aldehydes contains what? Hydrogen. While the carbonyl group of ketones don't contain hydrogen. The carbonyl group of aldehydes contains hydrogen. But the carbonyl group of ketones does not contain hydrogen. The carbonyl group of aldehydes contain hydrogen, but the carbonyl group of ketones does not contain hydrogen. The carbonyl group of aldehydes contains hydrogen, but the carbonyl group of ketones don't contain what? Hydrogen. Look at this ketone. And again, another thing with ketones. Ketones first member, the first three carbons, the first member of the ketone family is pro. So there is no met or there is no one or two carbon member for ketones. Ketones first carbon member starts from, because the carbonyl group must be in the middle carbon. And for there to be a middle carbon means there must be at least two other carbons beside. So there's nothing like met in ketone. Methanol does not exist. Met does not exist in ketone. These two do not, because for so ketones first member is propanone. The first member of the ketone family is propanone. You can clearly see that the carbonyl group in ketone does not have hydrogen, the carbonyl group in ketones does not contain hydrogen. You can clearly see it. But aldehydes, the carbonyl group contains hydrogen. Why does this one not contain hydrogen? Because it's in the middle. Carbon can only have 4 bonds. It cannot be bonded again. When joint structure of organic compounds, carbon can only have 4. So this is already 1, 2, 3. There can't be any bond here again. Class, are you seeing it? So this is propanone. 1, 2, 3. Propanone. But this is 1, 2, 3. Aldehydes naming end with propanol. Remember the aldehydes are also called alkanals. Aldehydes are also called what? Alkanals. Why ketones are alkanones? So aldehydes naming end with nals, ketones naming end with no. Aldehydes naming end with nals, alkanals. Ketones naming end with nos, alkanals. Nones. Aldehydes naming end with nouns, ketones naming end with noun. So we have alkanals, alkanones. So you can see this one is propanone, this is propanone. Class, you know one interesting thing? We did primary and secondary alcohol. Are you aware that primary alcohols, or let's put it this way, aldehydes are products can be are formed. Aldehydes, which are also called alkanals, right, are formed from oxidation of primary alcohols. Of what? Aldehydes are formed from oxidation of primary class. So when primary alcohols are oxidized, they give aldehydes. While ketones are formed from the oxidation of secondary alcohols. See why I wanted to do aldehydes and ketones mainly after that primary, secondary, and tertiary alcohol. Ketones are formed from oxidation of secondary alcohols. From oxidation of secondary alcohols. Ketones are formed from oxidation of secondary alcohols. Let's show you how aldehydes and ketones are formed from their respective alcohols. Let's show you how aldehydes and ketones are formed from their respective alcohols. If you look at the primary alcohol, for your primary alcohol, this is primary alcohol. Don't forget the definition of primary alcohol. It's an alcohol in which the carbon bearing OH group has 2 or more hydrogen directly attached to it. 2 or more. Why do we say 2 or more? Because this can also be a primary alcohol. Methanol, MET. Methanol has 3 hydrogens attached to the carbon bearing OH group. Methanol has 3 hydrogens attached to the carbon bearing OH. So 2 or more. So any carbon that is bearing the OH group that contains 2 hydrogens or more is a primary alcohol, or 2 or more hydrogens attached to it. Now, this is methanol, this one is propanol, this propanol. These 2 are primary alcohols. Class. Oxidation of primary alcohols will give aldehydes. We give what? Aldehydes are formed from oxidation of primary. We say aldehydes are formed from where? Oxidation of primary alcohols. These 2 are primary alcohols. So after they are oxidized, the name will change propanol to propanol. Don't forget, aldehydes naming end with now. And methanol will change to methanol. So instead of null, it's now. This is null, OL, but this is null, A. Aldehydes are called nows, alkanals. Class. So let's see what happens, what changes in the primary alcohol that makes it, that turns it to what? To an aldehyde. What am I saying? Or should be propanol to give propanol after oxidation, after oxidation, methanol will give methanol. Class, during oxidation, oxidation means addition of oxygen or the removal of hydrogen. Class, anything that causes addition of oxygen to an organic compound is oxidation. Or anything that causes removal of hydrogen from an organic compound is also oxidation. Class, oxidation occurs here by removal of 2 atoms of hydrogen. Oxidation occurs here by removal of what? 2 atoms of hydrogen. Oxidation occurs here by removal of 2 atoms of hydrogen. So class, don't forget that when organic compounds want to react, it must take place at the functional group spots. So class, all reaction will take place in these spots. Nothing will take place in this side. Note, anytime organic compounds want to react, it is where the functional group is situated that the reaction will take place. That's why we say functional groups are the ones that determine the chemical identity of an organic compound. So class, we need 2 hydrogens to go from here. Clearly, one must go from the OH, but OH is the chief functional group, and any of these other hydrogen will go. Class, if this hydrogen has gone, and this one of these hydrogen, let's pick any of them can go, anyone, no one is wrong, and this one goes. There will be a deficit here, there will be a space. Class, let me show you what will now happen. the resultant effect of two hydrogens leaving propanol. The resultant effect of what? Two hydrogens leaving propanol is that a double bond will be formed. Class, what is left? If this hydrogen and this hydrogen has gone, is that you're having O, you're having H, and you're having nothing yet. This hydrogen has gone. And you have this and you have this. Class, because there's nothing here, this bond will leave here and come and form a double bond here. And of course, anytime you have this now a carbonic group, now C double bond, and 1, 2, 3. Instead of propanol, don't forget the carbonic group must have hydro for aldehydes. Carbonic group has what? You can see the hydrogen is still here. So that's why it's the primary alcohol that undergoes that what? That changes to what? Aldehydes. Because the primary alcohol has enough hydrogen so that even if 2 goes, another hydrogen is still remaining to be with the carbonic group. Because you cannot cause one an aldehyde if the carbonic group does not have one. Remember I told you that aldehydes carbonic group has hydrogen. So now this is now propanol. Propa what? Now the same thing can happen in this methanol to methanol. Class, 2 hydrogens must go. This one even has enough hydrogen. Any of these 3 can go, but 1 must go from this OH because it's the main functional group. It's the main functional group of this leg. Of this my own leg. If these 2 hydrogens have gone, see what will be left? This H has gone and this H has also gone, so this day is free. This bond will transfer here and the double bond is what? Formed. And this methanol. So class, when we set aldehydes, the carbonic contains at least 1 hydrogen. It can be more than 1. For example, look at this aldehyde. It contains 2 hydrogens. This aldehyde contains 2 hydrogens. Class, let's see how secondary alcohols oxidize to give ketones. Let's see how secondary alcohols oxidize to give what? Ketones. Let us see how secondary alcohols oxidize to give ketones. Let's bring a secondary alcohol. Who is a secondary alcohol? It's an alcohol in which the carbon-bearing OH group contains what? Only 1 hydrogen attached to it directly. This is a secondary alcohol. The carbon-bearing OH group, remember in the definition, contains only 1 hydrogen attached to it. What? What happens during oxidation is that the 2 hydrogens will go. This is the center where oxidation must take place, where the functional group is. So these 2 hydrogens have gone, and what is now left is this class. We have entered draining seasoning. This hydrogen has also gone. So this bond is left vacant. It will come here and form what? A double. And then you see that this is a ketone. Remember that ketones do not have any hydrogen attached to the carbonic group. This is propa, no. Propa what? No. Propa, no. These are ketones are formed from oxidation of what? Secondary alcohol. So secondary alcohols undergo oxidation to give aldehydes. So to give ketones. Primary alcohols undergo oxidation to give aldehydes, right? Primary alcohols undergo oxidation to give aldehydes. Secondary alcohols undergo oxidation to give ketones. Last, note that tertiary alcohols do not undergo oxidation. So in the exam, it could be that which of the following alcohols will not undergo oxidation. They will not say A primary, B secondary, C tertiary. They will just put examples, structures, different structures. They want you to use your eyes and see, recognize the tertiary among them. So nobody will ask you a question like a primary school student, A primary, B secondary. No. They will just put structures of primary, structure of secondary. A can contain a primary structure. B can contain a secondary structure. C can contain a tertiary. They expect you to now notice how. So you must first be able to recognize who is the tertiary alcohol. You look for the structure that has the carbon bearing the OH group does not have any hydrogen attached to it. Don't forget, for tertiary alcohol, the carbon bearing the OH group does not have any hydrogen attached to it directly. The carbon bearing the OH group does not have any hydrogen attached to it what? Directly. That's the tertiary alcohol. Are we together, class? So when we come tomorrow, I was thinking